Let's look at another problem that we can solve recursively. That's the problem of calculating all of the permutations of a set of letters that you might have. Maybe this is something a little bit like the game Boggle, if you've ever played Boggle. But what we're generally interested in is creating all possible combinations of the letters in a string. So using recursion, we're able to do that. It's a little bit like taking all possible orderings of a set of colored pencils, I guess. All right, so how could we do that? How could we design a class that's going to list all the different permutations of a string? So let's just make clear what I'm talking about. All the permutations of a string would be all the possible rearrangings of the letters in which we include all of the letters. So the string EAT, E-A-T, for example, has 6 different permutations. EAT, E-T-A, A-E-T, 8, T, and T-A-E. These aren't all necessarily words, but that's not particularly our concern at this point. What our concern is generating all 6 of those permutations from our input of the string EAT. Move right. Here's an algorithm for how we could do that. In order to generate all the permutations of a particular string, we can think recursively. And we can think about, hey, how could I solve this problem if I knew the answer to a smaller problem? Well, if I think about that, I could first think about wanting to generate all the permutations that start with the letter E, then with the letter A, and then with the letter T. So taking each one of those letters out one at a time and considering it the first letter. Well, how would we do that? How would we generate all the permutations that start with E? Well, we would need to know what all the permutations are of the smaller substring AT, and then just prepend the E to that. But of course, figuring out all the permutations of the substring AT, well, that's just an answer to a smaller problem. So if we could solve that smaller problem, and we were to ask for all the permutations of AT, we would get back AT and TA, and then we could just tack the E on the front of each one of those permutations. We'd get EAT and ETA. Well, then we just have to make sure that we do the same work, starting with the letter A and doing all the permutations of ET, and starting with the letter T and doing all the permutations of EA. And by doing that carefully, we can generate all the permutations of all of the letters that are present. We need to make sure that not only are we making the problem smaller in our recursive call by calling our recursive function on a smaller string, we also have to make sure that when our string gets small enough, we stop recursing. And so we're going to have a special case, and that special case is when we are called for all the permutations of the empty string, a string with no characters in it. Well, that's an easy, simple final case. We'll just return the empty string back. And whatever letter needed to be prepended to it could be prepended to it. So that's pretty straightforward. That gives us the structure of a recursive permutation algorithm. So let's take a look at some code and see if we can figure that out.
Good morning, everyone. It is early on Monday morning. I'm in my man cave. That would be a corner of the garage where I'm far away from everyone, and so I can do this live coding exercise with you without waking everyone up. My man cave consists pretty much of a table covered with junk. And down here at my right, I got Dodger. I moved his pillow out here, and he's hanging out with me, but he's kind of sleeping. But you might hear his collar jingle in the background. What I want to do with you this morning is I want to walk through the example of making the code for the permutations recursive challenge or recursive assignment that is worked through in the book. This isn't an assignment that you're doing. And what I want to do is I want to go through it from scratch and let you see how I would go about coding it. Now, I'm going to code it in the way that occurs to me to do it naturally, and it might vary a little bit from the way you see the solution presented to you in the textbook, but just being able to look at those two solutions should be kind of informative to you about the kinds of design decisions that are available to you when you're writing code. All right, and just to reiterate, what we're doing here is we're trying to write a program that will take in a string, trying to write a class that will take in a string and will produce from that string all possible permutations of the characters within that string. So I'm going to get going. And so what I'm thinking immediately in my head is that I want a user class, I want a systems class, and I want a testing class. So I'm going to build it in this workspace over here that I had made for our class today, and actually it's the wrong date. So I'm going to rename it to the correct date. It might be today. You can see I got the triangle stuff in there. And I am going to create a new class. This is going to be the class that's going to use the permutation. So this will be, we'll call it permutation demo. And I'm going to put on my glasses here. This is where we're going to run our program from. And we'll give it a main class. All right, from here, I'm just going to go ahead and say, the way we'll run this is we'll take a string in from the user, and then we will permute it for them. So let's see. So let's make a new scanner, and we're going to put this in a try block. System.in, because we'll take it from the console, and we'll need to import scanner. Great. And so now I'm going to need a prompt. I'm just going to do this. All right, so what we're going to decide is whether or not we're going to take multiple inputs from the user, and we're going to go ahead and do that. And so after we open our input from the scanner, within this try-catch block, just a try block in this case, we'll go ahead and say Boolean done equals false. That clicking in the background is my solar panel coming on. And then we'll say while not done, we'll do the following. We're going to create a permutation object P. But the thing that we're going to want to pass into that constructor is we're going to want to pass in the string that we care about. So we're going to need some string that we care about. That's going to come from the user. So let's go ahead and create that and then prompt the user. Say, please enter a string to permute or empty string to quit. All right, we'll give it a space. There we go. And then we'll say permute me equals our scanner dot next, and that'll get the next string. Good. And then we'll say, then we'll check to see if the user's trying to quit. And so if it equals the empty string, then we'll say done equals true. And if it doesn't equal the empty string, then we'll do the work that we want to do. All right, so we have this new permutation class, which we haven't created yet, because that's the one where we're going to do our work. And what we're going to pass in is the string. That'll be the constructor, so we'll pass in the thing we want to permute as a constructor. And then I'll say make permutations using what we passed in as the constructor. And what I want to get back is I want to get an array list of strings, which are all the permutations. Then I want to output them. So I'll say, grab this up here, say, here are your permutations. And then I'll do a fast enumeration loop. Permutations. And we'll do one per line. And I will indent it with a tab character so that it looks indented. That'll go through that. All right, and that looks good. And then we'll go back up and we'll ask the user again for another input if necessary. So first let's import ArrayList. So we get that. And now permutation doesn't exist. That's what we're going to write. So instead of importing it, what I'm going to do is I'm going to ask Eclipse to create it for me. So you can see that first suggestion is to create the class permutation. So boom, I'm going to put it in the source. I don't want a main class because this is just a library class. That all looks good to me. All right. So here's our permutation class. Let me drop that over here. Let me give myself a little bit more space to work. All right, now clean this up. So for starters, there's no constructor defined. So I'm going to ask Eclipse to create a constructor. And what my constructor is going to do is it's going to say store the string that I just passed in. I'm going to use this, and I'm going to ask Eclipse to go ahead and create that for me. Now we don't use it anywhere, so it's getting a warning on line 5, but that's okay. Let me save everything, and we should see this go away. Great. Now we want to make permutations. That's a method that's not defined yet, so I'm going to ask Eclipse to go ahead and make that method for me. You can see It did so. And now we work through the logic of the algorithm of making permutations. So if you recall, what we did for this is, or in the lecture, what we talked about is we talked about first getting all the characters, and then getting all the strings without the characters, and then recursing on the smaller problem, and then prepending the characters to the smaller problem result. All right, and then one other thing I want to do is I want to make sure that we only return unique solutions. And what I mean by that is if the user types in some string that has multiple of the same character, then we don't want to, for example, if they type in the string EE, all the permutations of that string would be EE and EE if we think about each of those E's being different. But when we return them, the user doesn't care that they're different when they came in. They just want to see the one's EE. So we're going to get rid of unique ones by using a set. Coffee. All right. So let's start by going through and getting all the characters. I had to do a brief change of location there because I ran out of space on my hard drive. So what we were going to do is we're going to get all the characters from our string. So the string we're working with is permute_me, and the string method, or the string class has a method which will get the characters out of the string for us. You can look that up and find that on the string documentation at the Java website. So that's going to be permute_me.getChars. There we go. And the way that works is we give it the first index we care about, 0. And then the last index we care about is going to be permute_me.size. And then we need a character array that's going to hold our characters, so we'll make that in a second. And then we need destination begin. So where in that array is going to be the first index that we're going to put characters. All right, let me just look at that to make sure I got that right. First character is at source begin. The last character is source -1. Characters are copied in the array, starting at index SVM. Okay, great. So I double checked that. And size is not the right method. Is it length? There we go. And we don't have mychars. So let's go ahead and create a character array called mychars. And how many is it going to be? Well, it's going to be long enough to hold all of permute_me.length. Great. All right, so after that, we will have all the characters in the array mychars. Now we're going to want to get all the strings without the characters. And so what I'm going to do is I'm going to create a little map here. We'll create a map that maps characters, which is the characters we're pulling out, to the string that has the original string minus that character. And we'll say this is the, we'll call this the recursive calls. We'll say that's going to be a new hash map mapping characters to strings. And we'll import that. And we'll import that. And use the right thing there. Great. All right, so now we're going to go through and we're going to fill up recursive calls by going through each one of the characters in mychars and removing it from a copy of permute_me. So we're going to do a loop that goes through mychars. It's an array, so it's just .length, and each time we'll increment I. And then when we do this, what we want to create is we want to create the character that is going to be the one we're pulling out. Just call that C, and that's going to come from this list of characters that we created previously. That's going to be our key. And then our smaller string is going to be equal to permute_me dot replace first. We want to replace it with C, and we want to replace it with nothing. All right, so what happens there? we need to make a string for C. Okay, so let's see. Let's go ahead and say because replace first takes a string as its first character, not a character. So let's see. I just got to turn that into a string. How's that? All right. All right. So what that is going to do is it's going to replace any instance of the character that we pulled off with an empty string. So it's just going to delete that character, and then we're going to add it to our recursive calls. So one of our recursive calls is going to be taking the character C, and then the smaller string, that's what we have to recurse on. So I'm just building up a map that's going to be all the recursive calls that we need to make. And now we can go ahead and make those recursive calls. And when we do that, we're going to need a place to put all of the results that come back. So we want those results to be unique. So I'm going to make a set of strings that will hold all of our results. And now I'm going to go through our map one at a time. Actually, I think I'll make it a tree set because it'd be nice to have them alphabetized when we get them out. All right, now I'm going to go through each of our entries in the recursive calls. So I'll do a fast enumeration. Ask Clips to do that for me. All right. And so now what I need to do is I just need to make the actual recursive call. So let's make a new permutation. Smaller permutation equals a new permutation on the current string that we're working with. So again, this map recursive calls is going to remove one letter. The key of the recursive call, this character, is going to be the character that we're pulling out of permute me. And the string is going to be the string that's left over after we pull that character out. So when we do our recursive call, we're going to do our recursive call based on what was left over after we removed the particular character. So that just creates the object. Now we're actually going to do the permutation on the smaller set. Oh, sorry, not permute me, make permutations. And the results that are going to come back are going to be in a string, are going to be in an array list. And so we're going to want to go through that array list, and we're going to want to add to those permutations that come back the character that we pulled off. So we'll say permutations, that can work. Call it small permutation. Go through each of make permutations in a fast enumeration. And to our results, we're going to add the character that we're pulling off plus the permutation that we're currently working with. All right, and then we'll go through each one of them, make our calls. That's all great. And then finally, we just want to return everything back into an array list. Based on the results that we had. Great. All right, this is good, but we don't have a we don't have a base case. So let's just come up here and add a base case. Say if permute me. Wait, do we not have a base case? Nope. Okay, so if we were initialized with an empty string, then we're just going to return an empty array list. But we won't return an empty array list, we'll just return an array list that has one element in it. Let's do that. Don't really need the else because we've got the return. Okay, so I think that's it, but now we just need to go through the process of debugging. Before I debug, I want to make a JUnit test case. No point in not using what we've got. So my project over here doesn't have the JUnit test case in it, so I'm going to come down here to Properties. I'm going to add that library to my class path, libraries, class path, add library, JUnit. Great. And I'm actually going to, I don't like this module business yet because I don't understand it very well. So I'm going to move my system library into my class path. Okay. So now I've got my permutation class and I need to add some tests to it. So I'm going to go ahead and create a new JUnit test case after highlighting that. Permutation test, I don't need any of that. Next, I want to test make permutations. And Eclipse will write a basic test for me here. All right, so what do we want to do in order to test it? Well, we want to create a permutation. P, that's going to be a new permutation. And we know that if we have an empty string, we want to make sure we get back the empty string. So we want to do a couple things. We want to say, let's get the result back of this. This is predicting what we should be getting back. All right, so we want to assert a couple things. We want to assert that the size of this is 1 because it should be getting back the empty string. And then we want to assert that the first thing that we get back is equal to the empty string. All right, so that's a basic test that we can run. Let's go ahead and run that test and see how we do. All right, we passed that test, and you can see over here on the right side that the code that we ran was the base case, so that looks pretty good. So now I'm going to rename this to test base case. And now let me add one more test where we're not doing things quite so simply. We'll say test a simple case. And we'll just permute the letter A. And what we hope we're going to get back is something that is of size 1, and the only element in it is an A. So let's try highlighting that and running that as a JUnit test. Great, so that actually ended up running all of our code because we needed to go through each of our bits and then run the base case and a recursive call. So that's good. And let's do one more test with a more complicated case. Let's start with the eat, and we know that we should get 6 things back. And we don't know necessarily what they're going to be. So how do we want to test to make sure that we got the right answer? Well, we know that it should contain eat. So let's see, can we say answer.contains eat? Because if it doesn't have eat, then we know that we got a problem. And it's not assert equals, that's assert true. All right, let's just test that, see how that runs. Great, that passed, so let's go ahead and add the 5 other cases here. So we know it should be ETA, and AET, and ATE, and then TAE, and then TEA. Let's run that again. Good, and we passed that test too. So now we can run full JUnit test on that entire class. All right, and so we ran JUnit test. It's testing all of our code over here on the right. We feel good about that. Now we can go into the user-facing example and we can run that. We can say, okay, let's run our user application. Please enter a string to permute or the empty string to quit. We'll type in eat. And you can see we get back our answers. Please enter a string to permute or the empty string to quit. There's A. Good, we got one permutation. And finally, let's do something a little bit more interesting. Let's do something that has multiple letters in it. Make sure we don't get duplicates. So the word free, we can see that we get EEFR, and we shouldn't get EEFR again, which we don't because we used a set to hold our results. Let's hit enter to quit. Great, did it quit? No, it doesn't look like that is quitting. Looks like the way that in.next works is it's not actually checking to see, like hitting a return isn't returning an empty string. All right, so let's kill it, hard kill it, and then let's change what we do, or Q. We'll ask the user to type in Q to quit. And then we'll check if it's equal to Q, and if it is, we'll quit. Let's try running that again. All right, please enter a string to permute. Let's do a long one. Banana. There's a bunch of permutations, and then Q to quit. Great. So I think that does it. I'm going to ask you some questions about the code in the assessment, and hopefully, if you look at the way I did it and you look at the way the book did it, you'll get some insight into how the recursive problem works generally and some different design options that you have for pulling that off. All right, thank you for your attention.